Hi there, I'm John Michael with GMAT Ninjas, and welcome to Rates 2, the combined rates. Two rates going on in the very same question. Gadzooks. Is this video for you? First off, you're going to need to be familiar with these formulas, which, if we stop and look at them, are pretty much just one formula. If you are coming to grips with this and making the transition from mathematical practice to quant problem solving, you're in the right place. If you've been working at quant and maybe you've hit a bit of a plateau and you're trying to step up, you're also in the right place. Happy to have people who are beginning, happy to have people who are a bit stuck and trying to improve. What is the difficulty here? First couple questions should be pretty introductory. Going to get more difficult as we go. If the first couple of questions stump you, you have a lot of work to do. If the last couple of questions are very straightforward for you, tremendous. You're doing very well. Specific score levels are pretty difficult to judge, so I'm only going to speak in broad terms. And data sufficiency. Of course, that's part of data insights now, but we're still going to talk about it because you will see data sufficiency questions that speak very directly to rates and to combined rates. So we include them. That's enough. Let's get to it. Pick up your yellow pad, pick up your whiteboard, pick up your wet erase marker or your dry erase marker. If you're working with pencil and paper, pen and paper, okay, just remember that on test day, you're going to have that big, thick felt tip pen. Get used to it now. Okay, here's the question. Your target time is 2 minutes. I'll be back in 2 minutes. If you're still working, no problem at all. Just press pause. Without further ado, our first question. Okay, that is 2 minutes. If you are still working, absolutely fine. Press pause, carry on. If you're ready to talk about this question, let's talk about this question. So, very first thing I do, I read the question. Second thing I do, I read the question again. Every quant question we meet, we read it twice. First time, we get the big picture, we get a sense of what's going on in the question. Second time through, we actually look at the numbers, see how things are relating to each other. Every question is worth reading twice. The short ones, it costs you nothing to read it a second time. The long, complicated ones that you don't have time to read a second time are the ones that you most need to read a second time because they're long and complicated. They have lots of parts and pieces. Be sure you don't miss anything. Read every question twice. He leaves first, she leaves second, she's going faster, she catches him. Read a second time, I've got a bunch of details here. Super. What is it I'm looking for? Total miles he drives. Xavier's total miles. Pick a path. How am I going to get from all this information to that? And this is what I want to talk about. With combined rate questions, with every quant question, there are multiple ways to get to the correct answer. With combined rates questions, there are unusually lots of many ways to get to the correct answer. So I want to explore a few possibilities. Some people like to write an algebraic equation. And we know distance equals rate times time. Yep. I write this down all the time. If I have a quick little 3-part formula like that, I write it down. I love to look at it. I know exactly what I'm doing. So let's use lowercase letters for Xavier because he's going a bit slower. And we'll use uppercase letters for Yolanda. She's going faster. So when Xavier's driving, he's got some distance, which we don't know, and he's got a rate, which we do know, 80 miles per hour. And, well, how long does he drive? Well, we don't know that either. That's t. And when Yolanda drives, she covers some distance. She's got a different rate. She's got a higher rate. And how long does she drive? Well, we don't know that either. We don't just have to call it capital T because we know how it relates to Xavier's time. It's the time Xavier drives plus, minus 3/4 of an hour. So now I have two equations. I have two variables. I have three variables, except that if they're starting from the place and getting to the same place, they're covering the same distance. So his rate and his time is the same thing as her rate and her time. And I'm going to do something a little extra fancy here. I don't really want to do that distribution. It's not going to be pretty. But I wouldn't mind combining 80 with 3/4. So what I'm going to do, I'm going to say Yolanda travels for 95 times t, and Xavier travels for her time and a little more. Now I have some nice happy numbers that play very well together. I can do a distribution over here on the left. 80 t, 3/4 of 80 is 60, and that's 95 t. Move my t's over. 60 equals 15 t, and t time is 4. What's that good for? That's not in our answer choices. We are not done. We have found time. We have not found miles, and we have found our capital T. We have found how long Yolanda drives. So if she's traveling at 95 miles per hour for 4 hours, if I'm doing that, first I'm going to double it. If I double this, I have 180 and another 10, so that's 190, and I'm going to need to double it again. 380, that's the number I want, and it's here in my answer choices. An algebraic approach, building off a common formula and taking advantage of the information in the question to realize that I have just enough information. I don't have too many variables because distance and distance are in fact the same. There's one approach. Here's another. I draw tiny little drawings all the time. And when I say drawing, this is not much of a drawing. Here is Z Corp headquarters. Xavier takes off. He's driving at 80 miles per hour. And then, well, Yolanda waits a bit. I want to think about this. 45 minutes later, where is he exactly? 45 minutes later, he is 60 miles out. He has that head start when the race, if you want to think of it that way, when the race begins. He's carrying on at 80 miles per hour, and she's trying to catch up at 95 miles per hour. One way to think about the situation here is he has a 60-mile head start. And how fast is she catching up to him? She's catching up to him at the difference of their speeds. And if you consider, if you stop and want to connect that to the real world, if you're driving down the highway 60 miles per hour, someone behind you who's also driving 60 miles per hour, they never catch up to you. Someone who's driving 61 miles per hour will slowly catch up to you. And of course, someone who's doing 80 or 90 or 95 will overtake you very quickly. We're thinking about their relative speeds. So if the difference between them is 15 miles per hour, how long will it take her to close a 60-mile gap? 4 hours. We can again think of this as distance equals rate times time. We want to solve for time. That's going to be distance over rate. A 60-mile gap gets closed at 15 miles per hour in 4 hours. Remembering what we're solving for here, we're solving from Yolanda beginning to close the gap. So we're going to multiply 4 by 95 and wind up in the same place. One more possibility. We meet these quant questions and we figure out what's going on, we think about how we can approach it, and then we get the job done. And always multiple paths to the correct answer. We can always math our way through. Takes muscle, takes time, we're going to do a bunch of calculations. That will always work. Most GMAT quant questions are designed so that there's something else to notice about them, and if we see the connection, the relationship, we can take a bit of a shortcut. But if the shortcut is difficult or takes a long time to find, that's not necessarily efficient. Sometimes getting to work on a sort of laborious process that gets us there is actually the most efficient path to a solution. So let's consider, once again, we've got Z Corp headquarters, we've got Xavier, and we've got Yolanda. So here we are starting at 1:15, and in that first 45 minutes, he covers 60 miles. Then what happens? She starts driving at 2, and in the next hour, she covers 95 miles, and he adds another 80. That's 140. He's still out ahead of her. What happens in the next hour? She adds another 95. He adds another 80. We are at 190. We are up here. We're at 220. She still hasn't caught up to him. Another 95, another 80. What are we at now? We are at 582, and up here we are at 300. He is still out ahead of her. What happens next? What happens next? Add that in. 0, carry 1, and add that there, and they are at exactly the same place. That's pretty crude. That's pretty simple. It works, and it doesn't take very long. We have them coinciding at a nice round, even number of hours. If that was a half hour, we could sort that out. If suddenly she jumped ahead of him, then it clearly happens between the hours we're defining. As difficult as the GMAT is, it generally presents us numbers that work out pretty evenly. This gives us a very straightforward approach to what happened next. A word problem, we can follow the narrative. What happens first? What happens next? We follow it along, and there she is, catching up to him at 380 miles from their start. For the rest of this video, I'm generally going to pursue one way of thinking about a question. It doesn't make it the right way, doesn't make it the best way. The best way to solve a GMAT quant question is the way that you can see and can do and can get done in 2 minutes. So, lots of possibilities. I look forward to the comments down below that are going to point out all of the other ways we could do these questions. By all means, read them. Your fellow studiers are full of ideas, a lot of them Excellent. So, options and possibilities, work in the way that suits you best. And with that, we do another one. I'll see you in 2 minutes. Okay, that's 2 minutes. If you are working, press pause and keep working. If you're ready to talk, let's talk about this question. Okie doke. I read it once, I see the situation, machines together, machines apart, a classic. I read it a second time for the details, and the numbers look a lot less friendly than they usually do. Okay. What am I here for? I am here for time Q. Okay. What have I got and how can I get there? As we've said, lots of ways to get from the given information to a correct answer. When I have this kind of combined work question, I almost always set it up in the same way. I want to consider machine P, machine Q, and P and Q together. I want to think about the work they're doing. I want to think about the time they're taking, and I want to think about their rate. And yeah, I'm writing it very specifically in this order. I typically think work equals rate times time. Of course, we can swap them around. I'm very specifically setting them up in this order. What do I know? P and Q, when they work together, they do one order. Whether that's large or small, we don't know. They do one order in 3 hours and 12 minutes. And when P works alone, it does one order in 5 hours and 20 minutes. And we are here for that time when it comes to just one job. So we've got nothing in our rate column. And the rate column is where these sorts of questions come together. We want to be able to turn this information into a rate. And most of the time we get a nice round number here. It does one job in 3 hours. We can then say, well, it does 1/3 job per hour. And we have a reciprocal here, assuming we've got the number 1 over here. And as odd as these numbers may be, we can proceed in exactly the same way. So let's think about these numbers in another way, because this hours and minutes stuff is going to make us a little bit miserable. So what is 3 hours, 12 minutes? Well, that's 3 and 12 over 60. That's 3 1/5. And I'm going to go ahead and write that as an improper fraction. 3 in terms of fifths is 15/5, and I've got one more than that, so this is 16/5. So I'm going to say when they work together, they get the job done in 16/5 of an hour. Haven't changed anything, just saying the same thing in a different way. Here, it's a little bit easier to see. 20 minutes is 1/3 of an hour. 5 hours in thirds is 15 thirds. Add 1. Ooh, how friendly. And now if we want to talk about rates, we are talking about how much work gets done in time. So as we do when we have nice simple integers, we're going to say, okay, well, it does one job in 16/13 of an hour. It does 3/16 of a job every hour. And if we just check in with our human brains, that's about a fifth, 1/5 of a job every hour. Yeah, it takes 5 hours to get the job done. So, 3/16 of an order filled every hour. Here we do the same thing. One order takes 16/5 of an hour. We can sort this fraction out. When they work together, they do 5/16 of an order every hour. Again, checking in with our human brains, that's very close to a third, and we have 3 hours here. It does about, together they do about 1/3 of a job every hour. The job gets done in about 3 hours. And this rates column in my little table, and my table is slightly falling apart as things get complicated, but I have a 3x3 table here. My rates column is where the magic happens. We cannot add the work. Job and a job don't make two jobs. Job, job, job. We can't add over here. It doesn't make sense to add time. We know that when two machines work together, they don't take longer. But we can add rates. And so there's some mystery rate as yet unknown, which when we add it to P's rate, will give us the combined rate. And our weird measurements in time have turned out to be pretty convenient fractions. Obviously, that has to be 2/16 of an order every hour. In the same way that we flip things to come over here, we're going to flip things back. And so 16/2, and we know that that simplifies to 8. After all of those weird numbers to set us up, we've got some tempting, strange options. Our correct answer is 8 hours. Want to check in with the question, make sure we have an answer that makes sense. We can think about this in a few different ways. If we had another machine that worked just as fast, they would go to half the time. That would be 2.5, just over 2.5 hours. Well, we're kind of well above that. So the machine that's showing up to help is not nearly as efficient as P by itself. We need to get pretty considerably bigger than that, and it so happens that we don't need any minutes left over. Yeah, our answer of 8 works pretty well. Super. On we go. Treat yourself to a breath. Get a good grip on your pen, and have a go at this one. Okay, that's 2 minutes. If you're working, press pause. Otherwise, let's dive in. Okie doke. I read the question. We've got one setup, doing some work. We're looking for a different setup, doing similar but different work. Read it again, get all my details, think about what it is I want to find. How many additional machines? Okay. Going to grab hold of the numbers I've got. Going to try to get to some other number. And yeah, this is not too different from the previous question. I still want to think in terms of work and time and rate, but now I don't have an A, B together sort of situation. I have lots of machines. I have 6M machines. What do? They get a single order done, and they do it in 5 hours. And I mean, now we're in a kind of different sort of situation. We know that we want 2 orders, and we want it done faster, but we're looking for something kind of completely different. We're looking for that. What is the worker that gets that job done? How many machines is that going to be? Similar to the previous question, quite different. Once again, the solution lies here in our rates column. If 6 machines get an order done in 5 hours, then they get 1/5 of an order per hour done. And that makes good sense. We now have nice integers. Whew, thank goodness. And over here, putting these together in the same way, this unknown number of machines, that's the rate at which we're going to want them to work. If they get a double order done in 3 hours, then they're going to do 2/3 of an order every hour. Yeah, that will get us there in the given time. So pausing to problem solve, how do we get here? We need to know our number of machines together. So we need to think about machines separately. If 6 machines work that quickly, then a single machine is contributing 1/6 of the work. It's doing 1/6 of a fifth of an order per hour. A single machine does 1/30 of an order per hour. And now we aren't simply adding things the way we were before, but we still have our chart. We have our table. We can think about it. If a single machine contributes 1/30 of an order per hour, and we want to get to this rate, well, 2/3 is 20/30. Nice round numbers. We need 20 of these machines. 20 is in our answer choices. We're happy people. What did we not do? We did not check in with the question. What is it we're here for? Okay, that time I was faking it. What are we here for? Additional machines. We started at 6. We want to get to 20. How many are we adding? We are adding 14. And this, dear friends, is why we read the question one more time after we've done all of that beautiful calculation. The worst situation you can be in is to make no mistakes, to see the situation, to pick yourself a good path, to follow it cleanly, to get to perfectly good numbers, and miss the question because you didn't give them what they asked for. Okay, it might be worse to miss a question because you forgot to carry the 1 when you did an addition. Silly mistakes, banish them. Other than that, what a situation to be in. Check in with the question, make sure you have found the thing you were asked for. The test will always ask you, are you sure you mean to answer D? Nope, I want to answer B. Excellent. On we go. Here's another. Okay, that's 2 minutes. If you're working, pause. Otherwise, let's talk. Have a look at the question. Combined work, pumps together, pumps apart, no problem. What are we here for? How long? Time, slow pump. Okay. A bit different from the other two, but we can set ourselves up for the same sort of a situation. We have work being done, we have time taken, and we're going to get some kind of a rate. What do we know? When they are together, maybe I'll put this down at the bottom, when they are working together, they drain a single tank in 6 hours. When they work separately, still the same job, draining a tank, A takes 2.5 times as long as B. And this expression, as long as tall as many as, can often create a little moment of confusion. Wait, which is the greater? How are we to understand that English? A takes 2.5 times as long as B. So if B takes some time t, then A takes 2.5 times as long. Okay? And what are we here for? We're here for the time for the slower pump. We're going to need our t. That's our variable. Super. I'm going to go ahead and rewrite this as an improper fraction. That's 5/2t. And all the magic happens in the rates column, so we want to get there. If they're working together, they get the job done in 6 hours. They do 1/6 of the pool every hour. Tank, I beg your pardon. That's why we read questions carefully. They aren't draining a pool, they're draining a tank. They drain 1/6 of a tank every hour. And B, that's pretty straightforward. 1/10 of a tank every hour. And here, be sure you flip this fraction correctly. If we get quick about this, we're going to say, oh, I take the reciprocal. The reciprocal of 5/2 is 2/5, and I have flipped my fraction. Watch out. We are putting work over time. The work here is 1, and the time here is 5/2t, which we're going to write as 5t/2. Get your t in the right place. Now we can flip it over, and we have the kind of odd looking figure, 2/5t tank per hour. If we've got that straight, all the magic happens in the rates column. Add the individual rates to get the combined rate, and we are saying that 2/5t plus 1/t equals 1/6. A few things we could do here. I think I'm just going to get everything onto one line. When I have algebraic equations operating on 2 lines, I often like to just get rid of my denominators. A term that will get rid of everything here, I'm going to multiply the whole equation by 30t. My first term, that's going to cancel to give me 6. 2 times 6 is 12. Here, I just have my t canceling. 30 times 1 is 30. And over here, 6 is going to cancel with the 30, but the t is going to remain. I have 5t. Add these two things together, and we've got 42 equals 5t, and we've got t equals 42/5. Improper fraction, that's 8 and a little bit, and we've got 8 and a little bit, but we don't fall for that anymore. What are we here for? We're here for the time that the slow one takes. This number here is our t. A takes 2.5 times as long as B. So if that's the time for the faster one, we want to multiply it by 2.5, which is 5/2. And son of a gun, if these numbers don't work out very conveniently, 5s cancel, 2 goes into 42, and we have 21 hours for the slow one. And we're happy people. Here, we're given a relationship rather than hard numbers. Absolutely no problem. Works in the same way. Enter those. Make sure those numbers are useful. Make sure you're flipping things over the way that you should. All the magic happens in the rates column. It's a doddle. What's to worry? Here we go. Let's do another. Okay, that's 2 minutes. Pause if you're working. Otherwise, let's talk. I have a read here, and oh boy. As I said at the beginning, when we've got a long, complicated question, those are precisely the questions we need to read twice. We read them all twice. But to think that because there's a lot there, you should get to work right away, you be careful. I want to read through a first time, get a sense of the situation. Seems like a classic question. 2 trains coming towards each other. Okay, I can do that sort of a thing. Read a second time, find the specifics, find the numbers, see what it is they're asking for, figure out how I'm going to get there. As ever, I'm going to note, what am I looking for? How long had A been traveling when B left Eastville? I'm going to go ahead and call that A's head start. And head start in terms of time, because I could give you a head start in terms of time, let you go, and then take off after you. I could give you a head start in terms of distance. We're here for the time. And this question is sort of a familiar situation, but also a bit different. So before I solve, I want to plan. But before I plan, I want to understand. So I'm going to grab hold of the situation I'm given here. And really broadly, we know that we have our western place and our eastern place, and we have one thing going towards each other and the other thing coming towards each other. That's our basic setup. Let's put some numbers on here. We know that they pass in the middle at 12 o'clock. Since leaving Westtown, A's been going east at 40 miles per hour. B's been coming this way. It left at 10, traveling at 25 miles per hour. They are a total of 160 miles apart. And we're looking for how long A had been traveling when B left. So we can sort of think in terms of what was the time of its departure, and the difference in departure time and departure time will give us the head start. That's one way to think about it. But there's something here where A gets its head start, and that's kind of what we're interested in. So I could write an equation. I think I could try a few different things. I'm going to grab hold of what seems to me the most grab-holdable piece of information. Train B was traveling for 2 hours from its start to the meeting point. 2 hours at 25 means that this meeting point happened at the 50:110 mark. Okay. And well, when did B leave? 2 hours before that meeting. Where was A at that time? Well, at 40 miles an hour, it was 80 over here, which means we've got 30 miles unaccounted for. 50 miles that B does and the 110 that A does are broken in two parts. These happen simultaneously, and this happened before. So how long would it take a train moving at 40 miles per hour to cover 30 miles? 3/4 of an hour, which is 45 minutes. And in the end, I haven't written an equation. I've used the information given, I've connected it to each other, simplest drawing imaginable, and I've got myself a perfectly good answer. Sometimes we're going to do something very sophisticated, sometimes we're going to do something pretty simple. Simple doesn't mean easy, complex doesn't mean difficult. This question is complex, but just because it has a lot of parts doesn't mean that any bit of it is really all that difficult. Understand the situation before you make yourself a plan. Make yourself a plan before you get to solving. If you try jamming this information into forms you already know, you might get into trouble. You should get to a correct answer, but maybe it's a roundabout way. Okay, next up is data sufficiency. Pause, take a breath, clear your head. Think about how you approach DS questions, similar to these quant questions, but also a bit different. Prep your approach, grab hold of your pen, and off you go. Okay, that's 2 minutes. Pause if you're still working. Otherwise, let's talk. Data sufficiency. Oh boy, oh boy, oh boy. First thing I do in DS, I gather my given information, and I'm told that I've got 3 machines, and I'm told that J and K are 6 hours. They've told me something. And so we are looking for the JKL time. And I always like to include a question mark to remind myself this is a thing I don't know. That's what I'm trying to get to. To push the question a bit, I'm looking for the JKL time. I have the J and K time. I think my L time would be sufficient. If I had that and could add it to this, I think I would know everything I need to know. So I set myself up with the handy dandy answer grid, and I give myself a gigantic capital T. Statement 1. K on its own takes 15 hours. I don't want to do any more calculation than I have to. If I can see a thing logically, I'm going to be happy with that. If K takes 15 hours and I know that J and K take 6, well, I know that I could get a value for J, but nothing here tells me anything at all about L, which I need because I want all 3 of them. So I'm not going to do any more math than that. A is insufficient. 2 answer choices disappear. J and L together, their time is half the time of J and K. And this feels like we're getting somewhere. If we've got a half relationship, we might begin to think, okay, well, if that's 6, then half the time, then, and we might feel like we're getting close. If we've taken time thinking about this, we might be getting to the end of our time. So we say, yeah, I don't have it, but I don't want to calculate it. I think that's good enough. We have the time. Let's push a little harder. JL is half of JK. Well, what's JK? It's 6. So really what this statement is telling us is J and L are 3 hours. Okay, that's even more certain. I know more than I thought I did before. Super. But we just don't know how this works. We've got, it's possible that we have a feeble little j and a great big powerful k who are 6 hours, and we've got a feeble little j and a great big powerful L, and they're 3 hours. And when we put them all together, we've got 2 great big powerful machines, and they'll get the job done really fast. Alternatively, it's possible that we have a big powerful j and a feeble little k, a big powerful j and a feeble little L, and then when we put them together, we're going to have just one big powerful machine, and there's no way those are the same thing. We're going to get 2 different results. That's also going to be insufficient. Lots of different approaches we could take. This is my human brain kicking in and grabbing hold of the situation without actually putting numbers in. So B alone is insufficient. If I've got both of them at the same time, can I know all there is to know? Well, yep. From statement 1, I can have the rate of K. From statement 1, I can have the rate of J. And with that information, yep, statement 2 will then give me the rate of L. I'm going to have all 3 of their rates, put that all together, turn it into time. I beg your pardon. Once I have my L rate there, my L rate becomes time. We're not going to put them all together. We could do anything we want to. We don't have to. We definitely have all of the information we need. We're in a happy C situation. Very similar to things we've been doing, a bit more abstract. When we're in data sufficiency, we don't want to spend more time calculating than we have to. If we can reason and logic our way to a certainty, let's save ourselves the pencil lead. Okay, next up is our last question. Take a breath. back to Quant. Here you go.
All right, two last things. Thank you so much for making it to the end of the video. If you've made it this far, you're one of those awesome people that's obviously really engaged in this GMAT thing. We would love your comments and your feedback. If there's anything else you'd love to see in our videos, hit us up in the comments. We'll do our best to oblige. Second thing, if you're enjoying it, hit that like button, hit the subscribe button. Helps other test takers like you find our full free video course. You need anything else? You know where to find us, gmatninja.com. Thanks so much. Enjoy this last question.
Okay, that's 2 minutes. If you're working, you know what to do. If you're ready, you know what's about to happen. Read the question, combine work, no problem. Read the question a second time. Got some relationships, got some numbers, got some variables. Okay, fine. What am I here for? I am here for how long? So I'm in search of time for B to do 2W. Make a note of that off to one side. And yeah, I'm going to combine work situations. So I'm probably going to set myself up with work being done, time being taken, and a rate. And I have my two machines separately, and I have my two machines together. What do I know? Machine A takes 5 hours longer than B. So B is going to be some unknown time. A is going to be 5 more than that. To assemble W matchboxes. So that's a variable. 100, 600, don't know, W. If machines A and B working together assemble 1.5 W, a batch and a half, in 2 hours, how long does it take machine B? So yeah, we're here to find a time. And this is possibly the most typical of combined rate questions. You find the one. I think this might have been where we started. So, okay, no problem. We know that the magic happens over here in our rates column. And we have a W here, but we're talking about matchboxes per hour. So, okay, it's W matchboxes and it's T plus 5 time. I'm going to proceed here. I'm going to come back to this in just a moment. I'm going to go ahead this way. And so our rate here is like so. And over here, yeah, we've got something a little unusual. Not too strange. And the magic happens in the rate columns. The individual rates add to make the combined rate. So we can say something like this. And the first thing I'm going to do with this equation is to factor the common w out of everything, which is going to leave me with something a bit more manageable. And I just don't have to worry about w. I don't have to think about w. You know what? I'm never going to think about w. Having just walked through this, when I'm in this sort of a question, as I said, I have no idea how fast or slow these machines are. Maybe they make a couple hundred matchboxes. Maybe they make thousands, millions. I have no idea. So it could be anything, apparently. As long as we're sort of doing a job and a half here, it could be anything. It could be one. When I find myself in this kind of a situation, I'm just going to assume that they're making one matchbox. And now they're being asked to make a matchbox and a half. And the fact that that doesn't really make sense doesn't concern me at all. The mathematics will work out the same, whether they're making thousands or millions or just a couple. So the fact that it's going to take 6, 7, 8, 9 hours to make one matchbox, I don't know. Maybe it's solar powered on a cloudy day. I have no idea. So even though we've just been there, I'm going to come over here and I'm going to set up my rates column more straightforwardly from the beginning. This is 1 over t plus 5, 1 over t. And here I want to say that 1.5 is 3 over 2. So I'm going to go ahead and put 3 over 2 over 2, and that is 3/4. I'm going to write again the equation I just erased, but now I'm sort of coming to it forward with a bit more clarity. It's all happening on purpose. When I add my A rate to my B rate, I get 3/4. Super. We've seen this before. Algebraic equation on 2 levels. I want to hit both sides of the equation with some kind of a multiplication that will make all of that go away. Now, there's nothing in common here, so I'm going to have to multiply both sides of the equation by each of these denominators. On my first term, 1 cancels, the other 2 remain. On my second term, 1 cancels, 2 remain. And I'm being a little bit complete here. Some of you might be doing things 2 steps at a time. Entirely fine if you know what you're doing and do it carefully. Just go ahead taking things 1 step at a time. And over here, my 4 cancels, but I've got a 3 now. So I have 3 multiplied by these other 2 terms. Ready to do a little rewriting. T times 4, we call that 4t. Here I'm going to distribute my 4. Got another 4t, that's nice. And I've got plus 20. And over here, let's be sure we're thinking this all the way through. Kind of sort of distribute again, or we could think of this as 3t being distributed to the t plus 5. Doesn't matter quite how we think about it, as long as we're careful and clear. We're going to get 3t squared and 15t. So far, everything's being added. Nice and easy. We have not seen one of these yet. We have a squared term in a rates problem. A little peculiar, but okay. We have t squared, we have t terms, we have a constant. Feels like it's on the brink of becoming a quadratic. So let's make it a quadratic. I'm going to keep my first term positive over here on the right. I'm going to move everything over here to leave 0 behind on the left. I have 8t here, subtract that from both sides, and I'm left with positive 7t. And then my 20 moves across the equal sign like so. And this is where I know I make my mistakes. When I'm moving terms back and forth over the equal sign in an algebraic equation, I'm going to lose track of a negative sign. So I want to check as I go. I know that I'm on thin ice. That gives me 8t. Subtract it from both sides. 15 minus 8. 7 is good. Positive 20 comes across to become a negative 20. No mistakes so far. Kind of a strange quadratic. Some of you who have the quadratic formula all ready to go might be throwing these numbers into it. That's entirely fine. You do not need the quadratic formula to answer questions on GMAT Quant. We might do things a little bit by hand. This is not as bad as it may look. I want to think about this like any other quadratic. I put my parentheses in place. Typically, we put an x and an x into our parentheses, but of course it's 3t. So there has to be a 3t in one of them and plain t in the other. And now I know that my two constants here are going to multiply to make a negative number. So it's either a positive and a negative, or maybe it's a negative and a positive. I don't yet know what's where. Hold that in my mind. They need to multiply to make 20, and somehow with this 3 involved, they're going to add to make 7. This can feel a bit daunting. There are too many possibilities. It sort of spins out of control. You're going to be all right. What are the factors of 20? 1 and 20, 2 and 10, 3 is not a factor, 4 and 5. So we're going to be popping these numbers in over here. One of them is going to get tripled, and the difference between them is 7. If we want to be super methodical, if we triple the 1, we have 3 and 20, much too far apart. 1 and 60, much too far apart. Triple the 2, we have 6 and 10, that's too close. 2 and 30, much too far apart. Triple the 4, we have 12 and 5, which are 7 apart. The 4 needs to pair up with the 3, and the 5 is going to be the partner of the lone t. We want our end result to be positive, so these bigger numbers need to be positive, and this little guy is going to get subtracted from them, so there is our negative sign. Remember to keep the left-hand side of the equation. This is a place we're not too surprised to be in a quadratic. For these two things to multiply to make 0, one of them has to equal 0. Maybe it's the first one, maybe it's the second one. A little unusual, just because the GMAT usually feeds us nice integers. 3t is 5, t is 5 over 3, and over here we can say that t is -4. Quadratics generally give us 2 answers, not too surprising, but we only want 1. It is not possible for machine B to do the job in -4 hours. I don't know what that would even mean. It did the job before it started? I don't know. We can get mathematical results that aren't meaningful in the real world. Of these two possibilities, a negative number doesn't make any sense. This is our real t. T is 5 over 3. We're here for hours. 5 over 3 hours. Let's be super clear. That is 1 hour and 2/3. There it is. But we are not falling for it. Perfectly good answer. In the answer choices, check back in with the question. Make sure that you are answering the question that was asked and no other. We were asked the time it's going to take B to make 2 W matchboxes. We have solved for 1 W matchboxes. We need to double this result. The number we really want is, where to put it, 10 over 3. That is 3 and 1/3. 3 and 1/3 of an hour. D's our answer. Read for the situation, read for the specific details, set yourself up with a familiar structure. Simplify things as you go. We don't need to mess around with another variable. Call it 1 and have done. A quadratic turns up, we are unbothered. The GMAT is great at writing questions that include multiple concepts. If we go from one thing to another, we know how to do it all. If we meet something peculiar, we are undaunted. Eliminate the answer that makes no sense whatsoever, and be sure to check back in with the question. That is a lot to do in 2 minutes. You don't have to get it done in 2 minutes. You can go over. That's why 2 minutes is a target time. All of those questions you're doing in less time, they're providing you the opportunity to go over with something like this. If you are here at the end of 2 minutes, you have a path to victory. You can accomplish the rest of this in another 40, 50 seconds. Check back in with the question. This is a gettable question. And with that, I leave you to it. Tell me all about it down in the comments below. Share with one another other ways to get to the answers to these questions. I learn a lot from reading the comments. And happy studying. Hope you found this useful, and go get them.